It's interesting how some people insist that you need to eat sugar or carbohydrates to fuel your brain, but others who eat zero carbs still end up with high blood sugar. So, where does that sugar come from? If you are not eating it, your body must be making it from something else. So, how does your body create sugar from non carb sources? What kind of food contributes to this process, and why is it important to understand? Most people change their diet or lifestyle to lose weight, but there's more to it. Weight gain, type 2 diabetes, and insulin resistance are all closely linked. The real goal should be lowering blood sugar and insulin levels, because these markers influence more than just your weight. You can track these levels through blood tests, but to improve those numbers, you need to know which foods are causing them to spike so you can make better choices. This is where concepts like glycemic index and the insulin index come in. The glycemic index measures how quickly carbohydrates in food raise blood sugar levels. Unfortunately, it's not very useful because it only applies to foods with carbs. And carbs aren't the only thing that affects blood sugar and insulin. Plus, the glycemic index mainly focuses on high carb foods like bread or glucose itself, which have a high score. Even foods they call low glycemic may still spike your blood sugar significantly. The insulin index, which measures how food influence insulin level, is a better idea, but there's limited data available and individual response vary widely. So instead of fixating on these indexes, let's focus on understanding the mechanism behind blood sugar regulation. For example, take skim milk. It has most of its calories from carbohydrates, which digest more slowly than pure glucose but still raise blood sugar significantly. Whole milk has more fat, which slows down digestion, resulting in a lower glycemic and insulin response. Full fat cream, mostly fat with minimal carb, has a glycemic index closely to zero and a very low insulin response. Carbs have the biggest impact on both blood sugar and insulin. Protein has a moderate effect and fat slows things down. But what about people on zero carb diet who still have high blood sugar? That's where gluconeogenesis comes in. This is your body's way of making glucose from non-carb sources like protein or fat. For instance, when your body breaks down fat, the glycerol part can be converted into glucose. Similarly, protein is broken into amino acids, which can also be transformed into glucose. Ideally, protein is used to build and repair tissues like muscles, bone, and skin. But any excess that your body doesn't use for tissue is converted into fuel. Different types of protein vary in how much they contribute to tissue building versus fuel production. Insulin plays a role here too. It's primarily a storage hormone. It helps move glucose and amino acids into cells. Glucose can then be stored as glycogen or turned into fat if there is too much of it. Similarly, amino acids are stored as protein, primarily in muscles. However, the amount of insulin stimulated by protein is minimal compared to carb. Our body is incredibly resourceful. Even if you don't eat carbs, it can create sugar through gluconeogenesis. Understanding how this process works and which foods influence it can help you manage blood sugar and insulin levels more effectively. Next time you eat protein, remember it's not just about fueling your body. but also about how it gets broken down and used for energy or repair. Now, when you eat protein, your body can't absorb it as a whole. It has to break it down into individual amino acids first. Only these single amino acids are small enough to pass through your intestinal wall and get absorbed. Once inside, your body assembles them into new proteins with specific roles like building muscles, skin, or enzymes. Although there are hundreds of amino acids in nature, the body uses just 20 to make all of its protein. Out of those 20, 8 or 9 are essential, meaning you have to get them from your diet because your body can't make them. You might have heard the term complete protein, often in the context of comparing animal and plant protein. A complete protein has all 9 essential amino acids in the right amount. But if even one of those amino acids is missing, your body can't fully use the rest. If your diet doesn't provide all the essential amino acids, the leftover gets converted into glucose for energy, not tissue building. This is why variety is key, especially if you are a vegetarian or a vegan. But it's not just about having all 9 essential amino acids. It's also about the ratio. Let's say you have enough of amino acid A to make 2 proteins, but amino acid B runs out after 1. You can only make 1 complete protein, and the leftover amino acids from A get turned into glucose. This is called protein utilization, and it's a way to measure how much of the protein you eat actually becomes tissue versus how much is wasted or turned into fuel. According to studies, here is how scientists figured this out. Protein contains nitrogen, which isn't found in carbs or fats. They measure how much nitrogen you consume and compare it to how much leaves your body, for instance, through urine. The nitrogen that stays in your body is the portion of protein used for building tissue. Different foods have different utilization rates. For instance, eggs are one of the best sources of protein. About 48% of the protein gets used for building tissue. Animal proteins like meat, fish, and poultry are around 32%. Plant protein like soy, pea are much lower. Only about 17% get utilized. That means most plant protein gets converted into glucose and might raise your insulin levels. Even protein powders like whey, hemp, or pea have a similar issue. Despite being touted as complete protein, only a small fraction gets used to build tissue. Now let's talk about overeating protein, because that's a big factor too. Even if you eat a highly utilized protein, your body can't handle so much at a time. The amino acids that don't fit into your body's amino acids pool get turned into glucose and burned as energy. So eating more protein than your body needs won't help. It will just be repurposed as fuel. Now, a whole egg is one of the best sources of protein, with 48% of its protein being utilized by your body. But egg whites alone get utilized about 17%. It comes down to how the body processes these components. Egg whites are mostly protein and have a higher glycemic index of 55, meaning they can spike your blood sugar more than you did expect. What people often overlook is that the egg yolk not only has more protein than the white, but it also contains the missing amino acids that the white lacks. These missing pieces are why egg whites are only partially used when eaten alone. However, when you eat the whole egg, it becomes a complete protein, boosting its utilization significantly. That's also why the insulin index for a whole egg is lower at 21 compared to 55 for egg whites. Interestingly, 83% of the protein in egg whites gets converted to glucose, which explains why they have a higher insulin response. Let's look at some other foods. Remember, there's not a ton of data on this topic. Researchers started studying the insulin index in 1997, and there have only been a handful of studies since then, leaving us with some inconsistent numbers. So some foods like beef, for example, has been reported to have an insulin index anywhere from 15 to 51. Fish ranges from 12 to 59. The problem is that we don't have details on the type of beef or fish used in these studies or the fat content. It's hard to believe such wide variation if these foods have similar protein and no carbs. Now, when it comes to ground beef, there isn't much data available, but most animal proteins like beef, fish, chicken are utilized at about 30%, meaning about 70% gets converted into glucose. Fat content plays a big role in slowing the process down. So that's how your body makes glucose even if you are on a zero carb diet. This information is for educational purposes only, so always consult with your doctor or dietitian before making any major changes to your diet. If you enjoyed this video, do well to hit the like button and subscribe. Share as well so that others will receive it. See you in the next video.